Hello everyone. This video is continuation of basic dyeing of acrylic fiber. This is the third video of this topic. Before starting this video, we will just discuss what was studied in two previous video of this same topic. In the last two video we have discussed about the role of pK value. pK value means the pH value at which maximum ionization happens in the fiber in acrylic fiber due to introduction of the CO minus group, our CO minus ion, our SO3, our SO4 ion, and the role of pK value in dyeing of acrylic fiber. Also, we had discussed about the role of fiber saturation value, and how it play important role in basic dyeing of acrylic fiber. Now we will discuss about the dyeing property of acrylic fibers, how the level shade can be achieved in the dyeing. So to achieve the level shade, there is important prerequisite that there should be a proper migration of the dye molecules on the fiber surface. So cationic dye show poor migration below 100 degrees centigrade, but migrate above 110 degrees centigrade, and the higher temperature, and as the temperature higher, the better migration can be achieved. So as degradations of acrylic fiber starts at 110 degrees centigrade onwards, dyeing temperature is kept little below or at 110 degrees centigrade. So if you reduce the dye bath temperature, or we can say if you dye at 100 degrees centigrade, at that time the migrations of the basic dye or cationic dye is poor, so there may be a problem of uneven dyeing over the unlabeled shades. So the dyeing temperature is generally kept slightly higher than the boil, but not higher than 110 degrees centigrade, because after that point the degradation of the fiber is start. Special cationic dyes, which is a modified basic dye, which is specially modified or specially manufactured for dyeing of acrylic fiber. These dyes have bigger in structure, means the molecules of these dyes is bigger in structure and do not diffuse easily, and the dyeing process is very simple. So rise in dye bath temperature is not important, as these dyes do not react with polyacrylitol nitride below boil, because the cationic sides of the dye remain balanced with some other anionic molecules, and the dye do not show any affinity for the fiber, rather only gets deposited on surface at boil. Means these special cationic dyes, which have their molecules is bigger in size, they have property that they do not diffuse easily inside the fiber structure. Also, they are not temperature sensitive. These dyes not react with the fiber, acrylic fiber below the boil temperature. Means up to boil temperature, the cationic sides of dye remain balanced with other anionic molecules. That's why dye do not show any affinity below the boiling temperature. So the anionic halogen atoms at boiling temperature, the anionic halogen atoms split up and expose cationic sides of the dye. Means the anionic halogen atoms at boil split up and expose cationic sides of the dye, which then react with the fiber without using retarder, at least in case of the medium and deep set, because retarder work as a retarder just as a minimize the rate of dyeing. So producing of medium and deep set, there is no requirement of retarder. So at the boiling temperature, anionic halogen atoms, which is as a part of basic dye molecule, is split up at boil and expose cationic sides of the dye, which will react with the fiber, because fiber have CO minus group, either SO3 minus or SO4 minus groups. Now we will discuss about dyeing with basic dyeing, means the method. How we will dye acrylic fiber with basic dyeing. Before discussing method of dyeing, we will discuss why basic dyes are extensively used for dyeing of acrylic fiber in detail. All deep shades can be developed with greater ease because shades are brighter, excellent washing fastness, especially in case of special cationic dye, which is generally is synthesized for only purpose of acrylic dyeing. Maximum dye uptake is governed by number of acid group present in fiber, though a small amount of dye is held by dissolution process. So amount of dye or the depth of dye, it means we can say the dye uptake is governed by number of acidic group present in the fiber structure, that is COO minus group, SO3 minus group, SO4 minus groups. So the presence of these acidic groups by introducing the anionic monomer governs the basic dyeing process. Compatibility index of dyes for composite shade is very important. Compatibility index means how the dyes are suitable to produce a composite shade, means to produce a one shade. The number of dyes are mixed in a dye bath. These all dyes have compatibility with each other, so that can be measured in the compatibility index. So basic dyes have a good compatibility index. Basic dye can be dyed generally by two methods. First is non-retarded method. Second is retarded method. As name suggests, there is difference. There is a very general difference about the use of retarded. Here we will discuss non-retarded method. In non-retarded method, as the name suggests, there is no use of retarder in the dye bath. Here you see the dyeing cycle of the acrylic fiber with non-retarded methods. On the y-axis there is a temperature, on the x-axis there is a time. Initially dyeing is started at 40 degrees centigrade for up to 30 minutes. Then they raise the temperature up to 70 degrees centigrade with high rate of heating. After 70 degree the rate of heating will be reduced, and up to 70 to 80 from 70 to 85 degrees centigrade the rate of heating is minimized, that is 1 degree centigrade per minute, because at this portion especially after 80 to 85 degrees centigrade the maximum exhaustion of the dye bath takes place. That why here the rate of heating is controlled very preciously, and after 85 degrees centigrade the dye bath is raised up to 95 degree centigrade temperature very fastly, and hold for 30 to 45 minutes or 60 minutes depend on the percentage set or the depth of set, and then cool down the process. That is the dyeing cycle of dyeing cycle of basic dye with the non-retarded method. Here you see in the non-retarded method the exhaustion of dye bath takes place is maximum exhaustion of the dye bath takes place between the 80 to 85 degrees centigrade, that is approximately 80% of the total exhaustion which takes place, and this is because the temperature so 20% approximate 80% exhaustion takes place between 80 to 85 degrees centigrade, and the 20% the remaining exhaustion is taken up by up to 80 degrees centigrade above 85 degrees centigrade. That is the absorption of basic dye as glass transition temperature of the polyacrylonitrile. Here in the retarded method we have discussed about the dye profile, pH of dye bath, and how the dyeing is carried out, and what is the process of dyeing, and how exhaustion is affected. Our exhaustion is related to the temperature and how the leveled state can be achieved via controlling rate of heating process, because rate of heating is directly associated with the rate of dyeing, and rate of dyeing is directly associated with the exhaustion of the dye bath. So when the dye bath cross or near about the glass transition temperature of the fiber, the rate of heating should be minimized, because by minimizing rate of heating we can control the exhaustion, and via controlling the exhaustion we can achieve the level state. Thank you very much. In the next video we will discuss about the retarded method of basic dyeing on acrylic fiber.